This is an expansion on what I said in the previous slide, talking about the example with degrees of freedom equals 3 and the critical value at alpha of 0.5 one-tailed. So there's a narrative there at the top that may be of some extra help to you, but we'll go through a lot of these, and I'm hoping it'll be very reinforced at that point. So here's a depiction of T critical. So here's the T distribution when degrees of freedom equal 3. And you'll notice that 5% of the distribution is located in the tail beyond T equals 2.353 over here on the right or on the left. Now, again, it depends on what the nature of your problem was. But if I had a alpha of 0.5 one-tailed, I would either be picking 2.353 positive or 2.353 negative if I had only 4 subjects, which would make my degrees of freedom equal to 3, as we said here 2 slides ago. So if I had only an N of 4, it kind of punishes me a little bit. It makes that critical value of T considerably higher than it would have been had it been Z at 1.65. So again, we'll have plenty of chances, 5 different problems which will be depicting this. And of course, this is just a one-tailed example. What about 2, you ask? And of course, we'll get to that. So if we consider the entire table, some higher values of degrees of freedom are omitted, as we'll see. A close inspection of that T table will demonstrate a point we made earlier. As the value for degrees of freedom increase, the T distribution becomes more similar to a normal distribution. For example, examine the column containing T values for 0.05 proportion in 2 tails. You'll find that when degrees of freedom equal 1, the T values are gigantic. As you read down, you'll find that the critical T values become smaller and smaller, ultimately reaching plus and minus 1.96. You should recognize that as the Z-score that separates the extreme 5% in a normal Z distribution. So the bottom line is, when degrees of freedom increase up to a large number, the proportions in the T distribution becomes more like Z. When N gets bigger and degrees of freedom get bigger, the whole situation looks more like the Z tables. On the other hand, when the values for N are very small and degrees of freedom are very small, we get some huge critical values. And let me go ahead and go here. And I know this is it's a Xerox from an old Graviter and Wall Now text that I used, but this is the entire Z table. Now you'll notice what happens after I get to 30. It doesn't list every value. Holy cow. I don't have every value of degree of freedom. So let's say we had 37 subjects, and that would mean 36 degrees of freedom. Which degree of freedom should I use? Is it 30 or 40? And believe it or not, it's 30. We go down, which means up the table. I round down to be conservative. So an N of 38, degrees of freedom of 37 would mean that I'd use 30 degrees of freedom. If I had 500 participants, I'd use 120. We never use infinity, but infinity is listed there just to reinforce a point that your textbook just talked about. So let me go ahead and end this here, and I want to come back with a more thorough discussion of this particular table. I think you'll find it to be very manageable, and once we do a few problems, you'll have some good practice at it.